All right, so picking up where we left off, number 8. Um, use what you know about end behavior to match the polynomial functions with this graph. So we got 4 polynomial functions and 4 graphs. So what do we know about end behavior? Well, if you remember like this little sheet or things like it, we know that we look at the degree and we look at the leading coefficient. The degree and the leading coefficient. Now, when we're looking at the degree, ah man, I can't even spell. Okay. When we're looking at the degree, we care whether it's odd or even. And then if we're looking at the leading coefficient, we're looking at positive or negative. So I guess we can look at the equations and then try to figure out which one is which. So if we look at the first function, f of x equals 4x to the 6 minus 3x squared plus 5x minus 2. So what's the leading coefficient? It's 4. Is it positive or negative? So number 1 has a positive leading coefficient. And then what about the degree? Even. So what do we know about a positive leading coefficient and an even uh, degree? It it looks like a U. It starts high and ends high. Starts up and ends up, however you want to say it. So I look at the ones that I got and which one matched that? C. So 1 and C. So then we look at number 2. Number 2, f of x equals negative x to the 4th plus 1. So we look at the leading coefficient. What's the leading coefficient? It's a negative 1. Remember, if there's no number there, it's a 1. And so negative x just means negative 1. So the leading coefficient is negative, and then our degree is even, is 4. So we got a leading coefficient that's negative, and we got even degree. So what do we know about that? What is that behavior? It starts low and ends low. Yep. If it's even, it starts and ends in the same direction. That's another way you can think about it. If it's even degree starts and ends in the same direction. So I'm looking for which one of these graphs starts low and ends low. That's B. Starts low and ends low. Okay. How would you prefer me to do it? I'm putting 2 next to B because function 2 matches with B. Yeah, I mean the other way is you can have, I could be putting A and B or whatever up here. So I just thought it'd be easier to circle it. Okay, so now look at number 3. F of x equals negative 2x to the 3rd plus 5x to the 2nd power. So what's the leading coefficient? It's negative. Yep, it's negative 2. So we got a negative leading coefficient. And then what's the degree? It's odd. The degree, just in case you forgot, is the highest exponent that you got for your variable. So in this case, it's 3. So that's odd. So when we got a leading coefficient that's negative and an odd degree, what do we got? We got starts high and ends low. Starts high and ends low. So that puts me at D. Excuse me. And then finally, just process elimination. We know what the last one is, but f of x equals 6x to the 3rd plus 1. So the leading coefficient is number 4. The leading coefficient is positive. It's positive 6. And then the degree is odd. So when we got a leading coefficient that's positive and a degree that's odd, it starts low and ends high, which is A. So 4 is A. Does anybody have any questions? Okay, I'm sorry, only got one of these charts. We'll have to get something later if y'all want me to make them or something. Okay. Hmm. I don't remember that, but we can talk about that later. So let's see what else we got. Find 4 solutions for the following polynomial equations. Well, equation really. So what do we got? What this involves is factoring. It also involves the difference of squares, which is a squared minus b squared equals a plus b times a minus b. So if I look at this first piece of my expression, x squared minus 169. X squared is, x to the second power. But what about 169? What's that? That's 13 squared. So if I think about it like this, then I can factor that to x plus 13 times x minus 13. So that's the first piece. Now, my next piece is x to the fourth power minus 81. Even though it's to the fourth, that can still be cut in half. So that's x squared times x squared. So I can think of this one as x squared to the second power minus an 81. What's that? That's 9 to the second power. That's what the difference of squares lets us do. So I'm going to have x squared minus 9 times x squared plus 9. So everybody follow me there. Difference of squares. That little funky rule lets us break these things down. The thing is, this piece right here can be broken down further. It can be broken down further because we said find 4 solutions. Well, we got 1, 2, 3. Wait a minute. If you have x squared plus, you can't find a real solution for that. You get imaginary numbers and square roots and all kinds of ugly stuff. So we can't work with that one. But we can work with this one because this right here is also the difference of squares. Because that's x to the second power, and 9 is what? It's 3 to the second power. Oh, excuse me. So there's 3 to the second power. So I'll break that one down. X plus 3 times x minus 3. Now, I'm just going to put this mark on here so you know. So I don't even need to worry about that. I can find my 4 solutions. So how do I find the solution for this? I just set it equal to 0. X plus 13 equals 0. I subtract 13 from both sides and I get x equals negative 13. Right here, I say x minus 13 equals 0. I add 13 to both sides and I get x equals positive 13. Right here, I take x plus 3 and set it equal to 0. I subtract 3 from both sides and get x equals negative 3. And then finally, I got x minus 3 equals 0. I add 3 to both sides and I get x equals positive 3. So there are my 4 solutions. I didn't use that because I can't break that down. Does anybody have any questions? The difference of squares is what makes the difference on this problem. The difference of squares. All right. So now, what are the first and last terms of the following products? Well, product just means we're multiplying. So I got these 3 binomials that I'm multiplying. The first term and the last term just boils down to me multiplying all the first terms and then all the last terms. So the first term for this first expression, that's 2x squared times 5x times x. So what does that give me? Not 8. I'm multiplying it all out. What do I get? I get 10x to the fourth. 2x's, 3x's, 4x's. 10x to the fourth. And now I need to get the last term. So I multiply the last things. So I got 7 times a negative 3 times 4. 7 times a negative 3 times 4. Yep, it's negative 84. You can't forget the negatives. So 3 times 4 is 12. And then, well, excuse me, negative 3 times 4 is negative 12. Negative 12 times 7 is negative 84. And so then we do the same over here, right here. So x plus 8 to the third power is x plus 8 times x plus 8 times x plus 8. So what's my first term? It's just x times x times x. So that's x to the third power. And then we got the last term. That's 8 times 8 times 8. Well, we know 8 times 8 is 64. So we just take 64, multiply times 8. So that's 2 with a 3. That's 48, 49, 50, 51. So that's 512. Does anybody have any questions on finding the first or last term? It's just multiplying the first terms, multiplying the last terms. So now let's go to the next page. Okay, well, tell me when you're done. Now, we went over this before, but I want to go over it again because I'm recording it. So 11. You could do the long division method, but that was a lot of folks weren't comfortable with that. So we're gonna do the box method. So the box method, you make a box. It's a little tricky, and I didn't want to mess with that. Yes, it's a little tricky, trust me. So anyway, it's when you don't have when your leading coefficient for your x isn't 1. Like I said, it gets a little tricky. It, so anyway, I need to think about a box, right? How many rows it has, that's and how many columns it has, excuse me. Columns. Okay. So actually I did that backwards. How many columns and rows it has, and columns is going to be decided by the top expression. Rows are going to be decided by the bottom expression. So how many columns do we have, So I take the degree of the top. Oh, sorry. I take the degree of the top. So the degree of the top. And what's the degree of the top? It's 3. And then I add 1 and then subtract the degree of the bottom. So what's the degree of the bottom? Yep, no number means it's 1. So 3 plus 1 minus 1 means I got 3 columns. So I'm going to have a box that looks like that. And then I need to figure out how many rows I got. So I take the degree of the bottom plus 1. So the degree of the bottom we said was what? 1 plus 1 is 2. So I'm going to have boxes that look like that. That's a 3 by 2. So now that I got my 3 by 2 box, I'm going to place all of my terms around this shape that I made. So I'm going to start with the first one. 2x to the third power is going to point to this box. 7x squared is going to point to these two boxes. 13x is going to point to these two boxes. And then this last box right here is going to be where 5 points. And then on the end here, I'm going to put what I'm dividing by. So I got 2x plus 1. So what do I know about this? Because this is the reverse box method. What do I know about the box method? Well, I know that whatever I have up here times whatever's on the side gives me this thing that's in the middle. Well, I know that what's in the middle is 2x to the third power. So 2x times something is going to give me 2x to the third power. So what's that something? X squared, or x to the second power. So now that I know that's x to the second power, I can figure out what goes here. Because I've got 1 times x to the second power. So what's that? It's just x to the second power. Now, because I know that x to the second power is in this box, I can figure out what goes in here. Because this x to the second power plus this gives me 7x to the second power. So x squared plus what gives me x, or 7x to the second power. Make it easier on you. If I say this is 1x squared, 6x squared. So now I know that that's 6x squared. Well, now that I know that that's 6x squared, because we found out what was here. That's 1x squared, because we got x squared on the top and plus 1 on the side. So x squared times 1 is 1x squared. And then I subtracted here. I got 7x squared is the total of these two boxes. So I need to figure out, well, if I got 1, what else do I need to make 7? I need 6x squared. So now that I got 6x squared in this box, I think about what two things do I multiply to give me 6x squared? Well, I got 2x, 3x. And it's important that you realize that it's a positive. Okay? So positive 3x. Well, now that I got positive 3x right there, I can figure out what goes in this box. Yep, because 3x times 1 is 3x. And then right here, this is 13x. Well, I already got 3x. What do I need? 10x. Excellent. So now that I got 10x right here, I can figure out what goes up here. Because it's not 5. It is 5. 2x times something gives me 10x. Well, I only got 1x. So like y'all said, it's positive 5. Now, honestly, right here, this last box, because it's just 5 pointing to this box, I know that 1 times some number gives me 5. So I would have got 5 right there. So usually when you're doing this, you take that first box, figure out what you got up here, take the last box, figure out what you got up here, and then figure out the middle so you can get that. You don't necessarily have to fill out this whole chart, okay? So my answer is x squared plus 3x plus 5. Does anybody have any questions? Okay, this one, we're going to move to the side for a second. Let me know when you're done. This was one of the reasons why I didn't want to do this last week. Excuse me. Like I said, let me know when you're done. Monday or Tuesday. I was saying Monday, but for some reason, folks don't think Monday's a good idea, so maybe Tuesday. We'll see. We'll see. We'll talk about it tomorrow. All right. So I'm going to move over here and talk about a couple things. So we want to solve a quadratic equation. Right? We talked about several methods for solving a quadratic equation. The first one we talked about was just factoring. The second one we talked about was the AC method, which is just factoring with a little extra. And then the third we talked about was the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And then m2a. The last one, excuse me, the last one that we talked about was completing the square. It all depends on the problem, sir. I guess I'm just gonna write the problems down here as opposed to doing them on the paper. So let's start with the easiest one. Let's start with B. H squared plus 14h minus 32 equals 0. Okay, now you said which one's the easiest? This is the one I find the easiest, but it's all it's all relative to folks. So when I got a quadratic equation and I want to factor it, I need to look at the last term. Whoa, whoa, oh, that got a little out of hand. Let's try that again. No. So look at the last term. So the last term is negative 32. I need to figure out what two numbers multiply to give me negative 32. But when I add or subtract them, I get a positive 14. So I look at the factors of negative 32. So I know there's a negative in there, but I got 1 times 32. I got 2 times 16. And I got, 4 times 8. I look at which one of those pairs, when I combine them, is going to give me 14, right? Well, because this number is negative, that means I'm going to end up having different signs. It means I'm going to subtract. So 32 minus 1 is 31. 16 minus 2 is 14. 8 minus 4 is 4. So those are my pairs, or that's my pair right there. So I just give myself 2 parentheses. I got H 16. Oh, shoot, man, I'm dragging this. Hold on. Let's see if we can do this right without dragging stuff. Come on. All right. So we got 2 sets of parentheses. We got H 16. Dang. Sorry about that. And then we got H and 2. So now I just need to figure out where my signs go. Because I told you, because this is negative, that means one of them is plus and one of them is minus. So I look at the middle term. The middle term has the sign of the highest, the middle term tells me the sign of the highest number. So 16 and 2, 16 is the highest number. That's plus. So this is plus 16 and minus 2. And then the last thing I do is I take those and set them equal to 0 and then solve it. So h plus 16 equals 0. I subtract 16 from both sides and I get h equals negative 16. H minus 2 equals 0. I add 2 to both sides and get h equals positive 2. So those are my solutions for that quadratic equation. Negative 16 and positive 2. So now let's look at C. That's 8n squared minus 14n plus 3 equals 0. Now, usually, when you have a leading coefficient that is not 1, that tells you that factoring is going to be kind of eh. So we move away from factoring and we think about the other ones. Now, you could do it. It just takes extra work. And I'd rather not do that extra work. So we're going to do the AC method this time. So the AC method is I think of the leading coefficients for each of my terms for A, B, and C. So what's A for that first one? 8. What's B? Negative 14. It's important you keep the signs. And then what's C? Just 3. So now the AC method, draw me a big old X. I got A, C, and B. So what's A times C? 8 times 3 is 24. So it's important that you keep the signs. It's a positive 24. But then what's my B? A negative 14. So the reason it's important that you keep the signs, I need to think of two numbers that when I multiply them, I get a positive 24, right? But when I combine them, I get a negative 14. Yep, negative 12 and negative 2. Does everybody follow? Negative 12 times a negative 2, that gives me a positive 24. So now I need to factor. So I take these two things and replace that 14. So now I got 8n squared minus 12n minus 2n plus 3 equals 0. So now, well, we don't need to equal 0, but I'm going to, because now that I got 4 terms, I'm going to factor by grouping. So I'm going to group the first 2 terms together, and I'm going to group the last 2 terms together. So I'm going to say 8n squared minus 12n, and I'm going to say negative 2n plus 3. So let's factor these first 2 terms. Now I'm going to make it a little easier for you to see. 8n squared is 2 times 4 times n times n. And negative 12n is negative 3 times 4 times n. So now I look at what those things have in common. They have a 4 and they have an n. So that's what I pull out. That's what factoring is. So I say I got 4n, and then I write down what's left. So right here, I got 2n, and then right here, I got minus 3. So now I'm going to do the same thing here. Now, I want the thing that I'm factoring, I want the thing in parentheses to look exactly the same. And y'all can see what's off about those, right? The signs are off. So when you pull out, when you're not going to change anything and you're pulling out a term, you just pull out a 1. But in this case, I'm going to pull out what? I'm not going to pull out a 1. I'm going to pull out a negative 1. Now, why am I pulling out a negative 1? Yeah. If I pull out a negative 1, right, I'm going to get a positive 2n, because negative 1 times 2n gives me negative 2n. And then if I pull out a negative 1 from this term, I'm going to get a negative 3. So see, I ended up with the same thing under my parentheses because I pulled out that negative 1. And so now I just take these two things, put them together. So that's 4n minus 1 times, and then whatever's in the parentheses, 2n minus 3. Remember, the parentheses need to match exactly. So the last thing I need to do to solve this thing, I need to solve them. So I got 4n minus 1 equals 0, and 2n minus 3 equals 0. So I add 1 to both sides. Yes. So I add 1 to both sides and get 4n equals 1. And then I divide by 4 on both sides, and I get n equals 1/4. And then right here, excuse me, and then I add 3 to both sides, and I get 2n equals 3. And then I divide by 2 on both sides, and I get n equals 3/2. And those are my answers. Finding a solution for a quadratic equation. So that was factoring and the AC method. We got one more problem. We got A, which is p squared minus 10p plus 1 equals 0. So that doesn't work for factoring, and it doesn't work for the AC method. So we either have to use the quadratic equation or we need to complete the square. So how about we use the quadratic equation? So what's the quadratic equation? Negative b. Yep. Yep. Excellent, man. It's the little jingle that I played for you. Okay, whatever. X equals negative b. Okay, well, anyway. So now I just say, well, what's my A? What's my A? It's 1. What's my B? Negative 10. Got to keep the signs. And then what's my C? 1. So now I'm just plugging and chugging in here. So I got x equals negative 10. It's important that you realize that negative b, that negative is not part of the b. B in this case is negative 10. So negative 10. Hold up. Plus or minus the square root of b squared. So that's negative 10 to the second power minus 4 times A times C. So that's 4 times 1 times 1, all over 2 times 1. Does anybody have any questions? Tuesday, fine. Okay. All right. So I'll say one more time for the cheap seats. Does anybody have any questions? Okay, so now we continue. So I got x equals negative 10 is positive 10, plus or minus, plus or minus the square root of 100 minus 4 over 2. Then I got x equals 10 plus or minus the square root of 96 over 2. Nope, that's 64. So I need to break down 94. I'm sorry, 96. Wow. Yeah, need to break down 96. Wow, 94. 12 and 8. Okay. And then I need to break down, yes, please. I need to break down 12 and 8. So that's 4 and 3. And that's 4 and 2. And then I need to break down 4. 2 and 2. 2 and 2. You said stop recording? Is that what you said? Okay, then stop talking. So anyway, so then what do I got left? I've got 2, 2, 3, 2, 2, and 2. So when I got a pair, I can pull out something. So I can pull out a 2. I can pull out another 2. So that means I can pull out a 4. Nope. So I got 10 plus or minus, plus or minus 4 times the square root of 6, because I got 3 times 2 over 2. Awesome. If that showed up, I'm not posting it. Anyway, so last thing I got to do is I need to divide by 2. 5 plus or minus 2 square root of 6 is my answer. That's quadratic formula. What about, say it again? Because the 6 is under the square root. Remember, when something's under the square root and something's outside the square root, they don't interact. If there's two things under the square root, they interact. If it's two things outside the square root, they interact. Yeah?
That would have been the square root of 2.
Yes.
It would have been 3 square root. I mean,
I'm sorry, say that one more time.
if it would have that 2 at the bottom had been square root of 2, right?
Mm-hmm. Then yeah, you could do that.
Divided it.
Yeah, but that gets kind of funky because you can't have a square root in your denominator. But yes, you're right. All right, let me show you this. Oops. What are you talking about?
Or did I did the math wrong, but I had written to see.
Okay, well, give me a second.
Okay. I'll just.
No problem. Just give me a second. I'll look at it. Um, okay. So anyway, so let's see, 10p plus 1. All right. So I also want to show you completing the square. So this is what I got. All right. Completing the square. I start out by getting rid of whatever this term is. So I'm going to subtract 1 from both sides. And I'm going to end up with this. I'm going to end up with p squared minus 10p. Give myself some space equals negative 1. All right. Now I need to figure out what number needs to get put right here. Completing the square. So what do? I take my middle term, which is negative 10, and I divide it by 2. So I take the middle term and divide it by 2. So that's negative 5. And then I take that negative 5 and I take it to the second power. So negative 5 to the second power is what? It's 25. So that's the number I need to add to both sides of my equation. So I'm going to have p squared minus 10p plus 25 equals negative 1 plus 25. Now, this thing right here, the whole point of me doing that is to make something that I can factor. I can factor that now because 5 times 5 is 25, or negative 5 times negative 5 is 25. Negative 5 plus negative 5 is negative 10. So that lets me say that I got p minus 5 to the second power. That's why this is called completing the square, because I find out what number needs to go right here to make that a perfect square. So my perfect square is p minus 5 to the second power. And then I just finish that along for the ride. So negative 1 plus 25, that's 24. Well, I need to get to p, but I got p minus 5 to the second power. So what should I do? Hmm. I take the square root of both sides. I'm running out of room too. Yeah, might need to do that. So if I take the square root of both sides, I get p minus 5 over here. And then over here, I get plus or minus the square root of 24. Well, guess what the square root of 24 is? It's that. So I'm going to have p minus 5 equals plus or minus 2 times the square root of 6. And then the last thing I do is add 5 to both sides. So then I got p equals 5 plus or minus 2 times the square root of 6. I get the same thing I got there. Yeah, you'll be all right. All right. So that was all four methods. Mm? Okay. How about no? Are you done? Yeah. Oh yeah. I'm not mad. Why gotta be mad? Okay. That's true. I do always have something to say. All right. So let's look at 13. I'm gonna change 13 to that because I was trying to help you. No. That's an excellent question. No, you can't. No, you can't. All right. So anyway, if I can factor something, I need to factor it. If I don't need to factor something, I don't need to factor it. So, for instance, right there, I need to factor that. So x squared, that's ugly. Let's try that again. X squared minus 25, right? That's the difference of squares. That factors to x plus 5 and x minus 5. Now, x plus 10, I don't need to factor. But x squared plus 10x plus 25, I do need to factor. And that is what number do I multiply to get 25? When I add them, I get 10. It's 5. So that's x plus 5 to the second power. And then finally, I got 3x minus 1 squared. So now I need to look for all my solutions. So I solve each one of these. So I got x plus 5 equals 0. So that's x equals negative 5. Right here, I got x minus 5 equals 0. I add 5 to both sides, and I get x equals positive 5. Right here, I got x plus 10 equals 0. I subtract 10 from both sides, and I get x equals negative 10. Right here, I got the same thing that I got right here. So this is x equals negative 5. And then right here, I got 3x minus 1 equals 0. I add 1 to both sides. And I get 3x equals 1. Divide by 3 on both sides. And I get x equals 1/3. Now we just got to go back to do our multiplicities. Yep.
What did you get? Wait, so what did you do for the x plus 10? Oh, okay.
I'll show you.
I got it. I can.
You got it?
Yeah, I
Okay.
got it.
All right. So
You replace the middle one with that one that you have wrote.
this one right here?
No. Remember, okay, the one that you crossed off.
Yeah.
You replaced it with x plus 10.
Yeah. Yep. I replaced it with x squared plus 10x plus 5. So how many negative 5s do I have? Well, I got one right here. And then this one says square, so I got 2. So I got a solution of x minus 5 with a multiplicity of 3. That's why I wanted to do this one to show you that. Because I've got 2 right here and 1 right here. So that's a multiplicity of 3. Right here, I just got one positive 5, so that's a multiplicity of 1. Yep. Right here, I've got x plus 10 to the third power. So I've got x minus, or x equals negative 10 with a multiplicity of 3. And then the last one, right here, I got 3x minus 1 to the second power. So my answer, x equals 1/3, has got a multiplicity of 2. Okay. All right. So now I'm got solving a rational um, equation. So yes, you can go. I told you like 3 other times. I wasn't trying to record it. Okay. Because I said it 3 times. I was like, what's the deal? I was trying not to record him asking me to use the bathroom, but my fault. My fault. I apologize. Then why didn't you just come up here and ask for one? You could have just had me to pass. I was like saying you could go several times. There you go. Okay. So anyway, I've got a rational expression. Well, there's a couple things I need to do. First, I need to check my exclusions. What are my exclusions? What can't y equal because it gives me 0 in the denominator? Y can't equal 3 or negative 3. Next, I need to find out what my common denominator is. Well, in this case, 3 plus y times 3 minus y, that's the difference of squares. It gives me y squared minus 9. So that's my common denominator.
You need the exclusions on the test.
Yes.
No, you do not. You're not getting them.
Well, we don't know.
And that's on my stuff.
I don't know what that means, but okay. So anyway, so what do I need to do? I need to multiply that first fraction times y minus 3 top and bottom. I need to multiply that second fraction times y plus 3 top and bottom. And then the third fraction, I don't need to multiply by anything because it's already got my common denominator. You know what? Let's just give you that. Okay. So if I do all that and I sort of forget about the denominators for a minute, I'm gonna have y times y minus 3, or excuse me, 5. 5 times y minus 3 plus 2 times y plus 3 equals 3y plus 7. Say it again. Oh, no problem. No big. Okay, so anyway, so next thing I need to do is I distribute. So I got 5y minus 15 plus 2y plus 6 equals 3y plus 7. So let's write that over here. Y minus 15 plus 2y plus 6 equals 3y plus 7. So now I add like terms, stuff that's on the same side of the equal sign that's the same. So I got 5y and 2y, so that's 7y, negative 15 and positive 6, so that's minus 9, equals 3y plus 7. And so now I got an equation that I need to get the letters on one side and the numbers on the other, right? So I'm going to subtract 3y from both sides. And that gives me 4y minus 9 equals 7. And then I'm going to add 9 to both sides. That gives me 4y equals 16. And then I just divide by 4. Right? So I get y equals 4. So the thing is, I look at my exclusions to make sure that 4 isn't part of those. And then that's my answer. Yep. Okay, the last thing, last problem. Multiplying two fractions together, right? And so I want to factor and then see if I can cross cancel. Well, n squared minus 25, that's the difference of squares. So I can factor that to n plus 5 times n minus 5. And then I got 3n, and then that's times. I got 9n on the top. And now I can factor 4n plus 20. I can pull out a 4 from both terms. So now I got n plus 5. So now if I look at that, that's not 8, that's a 9. So if I look at that, I can cross cancel some stuff. So I can cross out this n plus 5 and this n plus 5. Now remember, when I'm cross canceling, when I cross something out, it doesn't become 0, it becomes 1. So like right here, that's 1 times n minus 5. And this is going to be 4 times 1. And now right here, I can cross cancel too. I can cross cancel out the n's because I got an n on top and an n on bottom. I've got 9 on the top and 3 on the bottom. I can divide both of those by 3.